Hello everyone, this is Mr. V. Hill. Today we're going to be talking about systems of linear equations. Now first off, just as a definition, a system of equations is nothing more than just more than one equation using the same variables. And in Algebra 1 we're just going to be only talking about two equations at the same time and only linear equations. So let's just look at an example. And here we go. Here's the system. How we usually write systems, we put one little curly brace out here and then the two equations just to the right of the brace. So we've got this equation here in standard form, 2x plus 3y equals 12. And then we also have this equation in slope-intercept form, y equals 5/3 x minus 3. And what we want to do is to solve this system of equations. Now, solving, well, from one perspective, yes, it is to undo what's being done to a variable. And at first it seems like that doesn't apply in this case, but it actually will. We're not going to get into that right now, but it might be a good thing for somebody to ask in class. But from another perspective, what it means is to find values of x and y that when we put them into this system, we get true statements out. Meaning that you plug the x coordinate in here and the y coordinate in here, and this will become a true statement. And the same thing in the second equation. So both equations, when we plug in the x and y, we have to get true statements out. And one way of figuring out what the x and y that will do that is to solve it by graphing. And so all we're going to do is going to graph both equations and see what points will make both of them true. Okay. So this first equation is in standard form. So with standard form, it's just really easy to figure out what the intercepts are. And so the y-intercept occurs when the x is 0. So if x is 0, 2 times 0 is 0, this term just goes away and we just need to solve 3y equals 12. So, of course, the y that will make this true would be 4. So the y-intercept is going to be right here at 4. For the x-intercept, well, the x-intercept is going to occur when the y is 0. So 3 times 0 is 0. We just solve that now for x. And of course, 2 times 6 is 12. So we just put the x-intercept right there. And after that, we just play connect the dots, because 2 points determine the unique line. And we just graph this very carefully to make sure we get this right. And there's the first line. 2x plus 3y equals 12. And so the idea here is that every point on this line, when we plug in the x coordinate here and the y coordinate here, we will get a true statement out. Now we're going to do the same thing for the second line. But now we're in slope-intercept form, so we have the y-intercept right here of -3. Plot that. And then we follow our slope of 5/3, meaning we rise 5 and then run 3. So we rise 5, 1, 2, 3, 4, 5, and then we run 1, 2, 3. Oh, isn't that kind of lucky? It looks like we landed on the other line. And so we graph this, play and connect the dots again. And that is our second line, y equals 5/3 x minus 3. And so the idea here is that every point on this line here will make this statement true. So we want to know what point will make both statements true. Well, that's going to be the point that is on both lines, meaning the intersection point. So this point right here is the solution to the system of equations. And that looks like the point 1, 2, 3, 1, 2. There's our solution, the intersection point. So that's what solving a system of linear equations really is finding the intersection point of the two lines given by the two equations here. Now, one thing we do want to do is we want to check our solution, just like when we're solving equations in one variable. So what we do is we plug these coordinates back into both equations and make sure we get true statements out. So we ask ourselves, is it true that 2 times the x coordinate 3 plus 3 times the y coordinate 2, is that actually equal to 12? Well, 2 times 3 is 6, 3 times 2 is 6, 6 plus 6 is 12. Yep, that one works. And then we also have to check the second equation. Plug it back in here. So 2, the y-coordinate, right there, is that actually equal to 5/3 times the x-coordinate of 3 minus 3? Well, 5/3 times 3, those 3's cancel out. That's just 5. 5 minus 3, is that equal to 2? Yep, it sure is. So yes, we did it right. And the solution to this system of equations is the point 3, 2. We could do this in set notation, but I'm not a big stickler for that. And just say that the solution set is equal to the set of just this one point, 3, 2. And that's about it for solving systems of linear equations by graphing. And so, of course, I'm going to leave you with a couple of practice problems here. First off, just is this point 2, 4 a solution to this system? Show your work or explain why. And then solve this system by graphing. Of course, show all your work, show your graph, and we'll check those in class. Thanks for watching.